Hi all, in this video we will discuss about Oracle database architecture. So what is a database? Database is nothing but a set of physical files which stores data. So here we have, this is the architecture of the Oracle database. So we have, we'll go one by one. So what we have two processes. One is user process, other one is server process. So what is this user process? Whenever a user want to connect to the database from the client machine, like any desktop or a client web portal or somewhere as some other tools. So wherever the user tries to establish a connection to the database at the user side, it will be a process will be created that is called user process. And when user wants to connect to the database on the database server creates a server process and it assigns that server process to the user process. So when what are the query user process request to the database, it will come to the server process and server process will take care of that execution of that query and it will return the output to the user. So until the user sign outs from his session, the server process will be assisting the user process. So you may be having a doubt like when we have, why do we have these two processes? We have these two processes because the user process cannot communicate directly with the database. So that is the reason we have user process and server process. So the server process which will be directly communicating to the database server and it will communicate with the user process with whatever the result the user request is requested. And next coming to the instance. So instance is nothing but a collection of memory structures and background processes. So what does this instance contains? This instance contains memory structures as well as background processes. So we will see what all the memory structures we have in the instance. One is the instance is nothing but a system global area. So what it contains? Memory structures such as database buffer cache, read log buffer cache, large pool, Java pool, streams pool, and shared pool. And again in shared pool we have three components. One is data dictionary cache, library cache. In library cache we have shared SQL and PL SQL procedures packages. So we'll see one after the other in bit detailed explanation. So let's and what are the background process we have? We have five. There are five background process, mandatory process which starts when starting the database. Those are database writer, DBWR, which is called as database writer, PMON, which is called as process monitor. Next, LGWR, that is log writer. Next is SMON, which is system monitor. And next coming to checkpoint, CKPT, that is called as checkpoint process. And other one is ARC, archive process. So out of these six, we have the five background process which are mandatory. Those are database writer, PMON, log writer, SMON, CKPT, checkpoint. These five are the mandatory background processes. So now let's see what is SGA and what it contains. So before seeing that, we'll see what is an instance. The database, it is a database instance. An instance is a set of memory structures that manages database files. So we see instance is a set of memory structures and background process. So we'll see what is SGA. SGA is nothing but a system global area. What does SGA contains? So the SGA, the SGA is a memory area which maintains internal data structures that are accessed by the many process and threads concurrently. So when multiple users are accessing the database, like updating and deleting the data, same data results, the data will be inconsistent. So this memory maintains the consistency of the data structures. So what What does SGA also do? SGA also allows not to change same data at the same time. And again, catching it also responsible for catching the data blocks read from the disk. And it also it is also a SGA is also a group of shared memory structures that contain data and control information for one Oracle database instance. If there are multiple users, if there are some multiple users are accessing concurrently connected to the same instance, then the data in the instance SGA is shared among the users. So it automatically allocates the memory for an SGA when you start an instance. So when you start the database instance, it will allocate the it will automatically allocate the memory for this SGA memory. And each and every database instance has its own SGA. The SGA is read write. All users connected to a multiple process database instance can read information contained within the instance SGA. Also, several process write to the SGA during execution of the Oracle queries. So now let's see PGA. So we have SGA, which contains the control information of the database instance. So what is PGA? PGA is called as Program Global Area. A PGA is a memory region that contains this is also similar to the SGA, but SGA will contain the control information on the instance level. So coming to the PGA, it is also a memory area which contains the control and data and control information for a server process. And this PGA is a non-shared memory area. It is created when a server process is started. And so this PGA is accessible by only that server process. It is an exclusive access to it is exclusive to that server process and is read and written only by the Oracle code acting on behalf of it. So the total PG allocated memory by each server process attached to an Oracle instance is also referred as aggregate PGA memory allocated by the instance. So whatever the PGA memory allocated to this to the each server process attached to an Oracle instance, we call it as aggregated PGA memory. Yeah, this is a PGA memory component memory area. So now let's see each and everything in a bit detail about this memory components. What is database buffer cache and these all we'll see a bit detail. So what are the memory areas we have? Database buffer cache, read log buffer cache, large pool, Java pool, and uh, shared pool. So these are all the uh, memory structures. So we'll see one by one in detail. So what is uh, uh, read log? What is database buffer cache? Database buffer cache is the uh, part of memory part of SGA. What it has? It holds the copies of the data blocks that are read from the data files. So it is shared by all the concurrent users. And we also have a catch it, catch, miss. So this will learn in future sessions. So whatever if a user runs a select query on the database, the results of the select query are copied to first database buffer cache, and then from there the server process will display the output to the memory user. So it will capture the output from the copies the output from the disk data files, and it will display the results to the user. So it store this database buffer cache holds the copies of data blocks that are read from the data files, and it is shared to the all the users who are the access to this database buffer cache will be shared by all the users connected to the database. So now let's see redo log files. So redo log buffer cache. So what is redo log buffer cache? Redo log buffer cache is a circular buffer in the SGA. what does this buffer cache contains? This contains the information about the changes made to the database. So whatever the changes made to the database, those information will be available in redo log buffer cache. So uh, the information stored in redo log entries. What is redo entry? Redo entry is nothing but a change entry. So if you have a table, you may be doing insert, update, delete, modify, create, alter, drop. These are all operations which we perform on the data. So the any change entry is nothing but a redo entry. So the information is stored in the redo entries. Read that the redo entries contains the information necessary to reconstruct or redo changes made to the database by any of the DDL or DML commands such as insert, update, delete, create, alter, or drop operations. And the redo entries are used for database recovery operations. So recovery operations. So this is about uh, redo log buffer cache. Redo log buffer cache contains the uh, change data. So now let's go to the Java large pool. So what is large pool? Large pool is a memory, one of the memory component of the SGA. SGA. So when we use the large pool, so large pool provides large memory allocations for session memory for the shared servers, and also it also used by Oracle database backup and used for database backups and restore operations, and it is also a optional memory. So whenever we do database backup and restore recovery operations, we use this large pool memory area. Then coming to the Java pool. So what does Java pool do? What is a Java pool? Java pool is a memory area which is used for server memory for all session specific Java code and data in the Java virtual machine. So whenever we use any applications which are using Java code, this Java pool will be used. And the Java pool is also, like it's the Java pool advisor statistics provide information about library cache memory used for Java and predict how changes in the size of the Java pool can affect the parse rate. So the Java pool advisor is internally turned on when statistics level is set to typical or higher. So next coming to the streams pool. So what is streams pool? Streams pool is a memory area, one of the memory area of the SGA, and it is used to exclusive by the Oracle streams to store buffered queue messages, and it also provides memory for the Oracle stream processes. So we have Oracle streams, right? So whenever we use the streams application, it will provide the stream pool will provide the memory for Oracle streams X process, and also yeah, this is streams application or replication purposes we use this memory area. Yeah, these are all the memory structures of the database, and also we have shared pool. So we will see about the shared pool. So what does shared pool contains? It contains again library cache, data dictionary cache, and PLSQL procedures and packages component. So we'll see what is shared pool. So the shared pool is a portion of the SGA contains library cache, data dictionary cache, result cache, and buffers for parallel execution messages and control structures. So we'll see one by one. So what is library cache? Library cache, what does this library cache contains? The library cache includes the shared SQL area, private SQL areas, and the case of a shared server configuration. Uh, PL SQL procedures and packages and control structures such as what if there are any logs and library catch handles. So let's see what is data dictionary catch. So in simple, library catch contains the execution plans of the SQL statement. So whatever the SQL statement, select statement, or any other SQL statements execute, every statement has an execution plan. Those execution plans are stored in the library catch. Next, coming to the data dictionary catch. So what is this data dictionary catch? The data dictionary catch is a collection of database tables and views that containing reference information about the database, its structures and its users. So Oracle database accesses this Oracle database accesses the data dictionary frequently when during the SQL statement parsing. So this access is essential to the continuing operation of the Oracle database. So whenever you execute a select query, suppose if you are selecting a select query, so what does this do when the query comes to the database? It has to check. It has to do some perform some initial checks. So what does it has to do? It has to see whether the table is existing in the database or not, and who is the user running the select query, whether that user is having access to this select query table or not. So these are all checks it has to do, or like who is the owner of the table, how many rows are there in the table. So whether the user requested table, right, that has the he has the privileges to access the table or not. These all data will be available in the will be checked in the data dictionary cage. So this data dictionary is accessed to so often by the Oracle database that uh, two special locations in memory are designated to hold dictionary data. One area is called data dictionary cache, also called as row cache, because it holds the data as rows instead of buffer. Yeah, this is about data dictionary cache. So now we'll see what the background processes. We will just see an overview of the background process. So what are the background process? Database writer, log writer, process monitor, system monitor, and checkpoint. So we'll see one by one what is uh, database writer. So this database writer is a background process which writes the dirty buffers present in database buffer cache to the data files on the disk. So and also this database writer process writes the dirty buffers to the disk under following conditions. So when the database writer is a background process which writes the dirty buffers from the database buffer cache to data files on the disk. So when does this database? There are some conditions when this database writer performs this operation. So what are the conditions? Let's see one by one. So whenever a server process cannot find a clean reusable buffer after scanning a threshold number of dead buffers, it signals the database writer to write the dirty buffers to the disk. So whenever the server process, when it is communicating with the user, it will not be able to find any clean area in the buffer to pull the fetch the data from the disk. Then it will signal the database writer to clean up the database buffer cache to write all the committed transactions to the disk, so that the buffer database buffer cache will be freed up, so it can the memory can be reused. And also database writer periodically writes buffers to the advanced checkpoint which is in position in the redo log thread from which the instance recovery begins. So also like whenever the checkpoint occurs, this database writer writes the dirty blocks into the disk data files on the disk. And also this Oracle allows a maximum of 20 database writer process. So that is when to speed up, suppose in some cases we have multiple transactions and huge number of transactions coming in the, so we can define the Oracle database allows a maximum of 20 database writer processes. So and again every 3 seconds this database writer process writes the data into the disk, and also whenever a checkpoint occurs it will write, and also whenever the database shutdown happens, then it will write the data to the from buffer cache to disk. So next coming to the PMON, process monitor. PMON is nothing but it's a background process which is responsible for process monitor. This process performs a process recovery when a user process fails, and also it is responsible for cleaning up of the database buffer cache and freeing resources that the process was using. And this process periodically checks the status of the dispatcher and the server process and restarts any that have stopped running. And this also registers information about the instance and dispatcher process with the network listener. So this is about PMON. So now let's see about log writer. So what is this LGWR? LGWR is a log writer. So what is this process do? This process is responsible for writing the log buffers out to the redo logs. Redo log. So it does the so this process normally writes the uh, the redo log changes from redo log buffer cache to redo log files. So this this writes fast enough to ensure that the space is already always available in the redo log buffer cache for new entries, even when the access to the redo log is heavy. So how when this redo log buffer log writer writes the data into the redo log file. So whenever a commit operation happens by user process, it will write the redo log changes from redo log buffer cache to redo log files, and every 3 seconds it will write the buffers into the data from buffers into the redo log files. So whenever the redo log buffer is 1/3 full, then it will write the in that condition also it will write the redo log data from redo buffer cache to uh, into the log files. So whenever DB writer process writes the modified buffers of this, if necessary, it will write the changes in the redo log buffer to redo log files. And also when a user commits to data, it will write the changes to the redo log files. Then we have SMON, which is system monitor. So what does this do? It is this process monitors the process performs recovery. Whenever the instance startup happens or instance failure occurs, it will clean. It is responsible for cleaning up the temporary segments that are no longer in use. Uh, yeah. Then next checkpoint, CKPT, we call it a checkpoint process. So when a checkpoint occurs, Oracle must update the headers of all the data files to record the details of the checkpoint. So whenever a checkpoint is performed, at each switch of the whenever the a redo log switch happens, so whenever the log file of the redo log happens and it goes to next log file, a redo log, we call it as redo log switch. So whenever redo log file is whenever the log file completes writing of one log and it will start writing to the another redo log file, we call it a early log switch occurs. We call it as a log switch. So at that point, checkpoint is performed. And also we have a parameter called log checkpoint underscore timeout, which is whenever we can define the time for that checkpoint interval. So whenever this interval reaches, it will perform a checkpoint. So what happens during the checkpoint? Whenever a checkpoint occurs, the database writer process will write all the modified database blocks in the buffer cache to data files, and also the checkpoint process updates the headers of all the data files to indicate when the last checkpoint occurred. So why does it write to the all headers of the data files? Because to maintain the consistency of the database, it will write the all the data, all the headers of the uh, data files. And this is about the mandatory background process, instance, and database.